Welcome you again for continuation of lecture. So before this lecture, we have discussed about solar angle geometry and concept of longitude and latitude, which are important for the installation of any solar power plant based on thermal energy of the sun. So now we are going to discuss about what is a global irradiation falling on the horizontal surface, global radiation on monthly average daily basis. So we have to find out daily incidence radiation falling on the horizontal surface taken monthly average. For example, for a whole of 30 days, we collect radiation and divide it by 30. So we can get daily global irradiance on the horizontal surface. This concept was first given by the angstrom and modified by the clean solar energy scientist. So why this is important? First of all, why we are going to study? Because we have to, anywhere you want to install solar thermal power plant, let's say solar collector or power generation based on the concentrating collectors. First, we have to study the location where what is availability of sun radiation. For example, if you are going to install power plant in those areas where most of the time there is a cloudy or rainy days. We can't go for Cherrapunji in northeast where most of the time there is a rainy days and cloudy days. So we have to study what is a maximum solar irradiance, what is a daily average solar irradiance falling on the horizontal surface. That is important. That's why we are going to discuss here. Global irradiance and formula given by angstrom was first we write a formula and define terms for finding out global monthly daily average of solar irradiance falling on the horizontal surface. This equation was given by the angstrom Hg upon Ho equal to A plus B in bracket S upon S maximum. Let us define these terms first. Hg stands for the daily average monthly basis. Means daily global irradiance falling on the horizontal surface. For example, you are taking Jaisalmer or any country, Japan, Tokyo, Nevada in USA, any London, any place you can take where global irradiance average daily monthly average of the global irradiance falling on the horizontal surface HOH daily global irradiance falling on horizontal surface per clear day means all days are clear means there is no any cloudy day, no any rainy day. So and A and B are linear constant based on the geographical location. S is a average daily sunshine of that location. X maximum is a maximum possible sunshine hour when there is a clear sky of monthly average of daily sunshine hour. Means here is a irradiance intensity and here is a sunshine hour. Average sunshine hour for daily average sunshine hour and daily average sunshine hour for maximum possible radiation. Means when there is a no any cloudy day, means we assume that no cloudy day, then what is the maximum average of the daily average? Monthly daily. Here monthly means for whole 30 days we collect data and divide it by 30 or 31 days, then we get daily average. But this one is based on there is no any cloud, and this one is based on the including cloud or rain or anything. So this will be always less than S maximum. So this was how to define clear day. It was very difficult to define clear day because even in clear day there is some scattering of light from the gases present in the atmosphere, molecules and dust particles and uh, moisture content. So it is was always difficult to find HO means clear daily average on monthly basis of solar irradiance. So this was modified by scientist Klein, and he said that it was earlier HC for clean day, stand for the clean. He defined it SC average, now replaced by the HO. Means he said that when radiation will be on the extraterrestrial region beyond the atmosphere of the earth, so there will be no any atmosphere, just like a plane flying very high from the atmosphere. You see that it was clear because it which a plane always fly above the cloud, and you see that clear sky, you see below the cloud. So he considered that HC replaced by HO, then concept of clear day is acceptable. Now there is no any doubt in defining concept of clear day, because in extraterrestrial region beyond the atmosphere of the earth there is no any disturbance to the incoming radiation. So on that day, for this will be clear, and which will be monthly daily average, because we have to find out monthly daily average. So he also defined clean that for each month there is a one day in the month of, there is a one day which represent of the whole of the month average. So for he defined all months. For example, for May 15 is a day where which represent average of the whole of the month. Average of the whole of the month. So you can take number of days n on May 15 will be equal to January plus February plus March plus April plus 16, because already we have taken 16th of May. So January equal to 31 plus February 28 plus March 31 plus April 30 plus 15. It will be 136. So n become, because we have to use n for finding out angle of declination. Angle of declination is defined as by using formula n equal to 23.45 sine 284 plus n 350 upon 355. By using this equation, you can find out declination, and n is always varying. Here n for day of the for month for May, month of the May, a day will be 15. That is representative of the monthly daily average of that month. So 15th May, whole of the number of day will be equal to 136. So this varies whole of the year. For example, on January 1, n equal to 1. On December 31, n equal to 365. So n is always varying, so del is also varying. Angle of declination is always varying, and phi angle of latitude depend upon the geographical location of the point of consideration. Here now we see here how to find out HG, means global average irradiance falling on the Earth's surface, a point of observation that we want to calculate. So here equation is Hg upon Hc was equal to A plus B and S bar upon S maximum. Generally S bar is given because daily on that day you can find out what is a, for 16th May you can calculate what is a day up, what is a total irradiance by using a sunshine measuring instrument. You can find out S bar, means average of the radiation for whole of the month. You can find out S, because data is already available for month of any month. You can find out data. S bar means average sunshine for a particular month, and ABR linear shooting constant. It also depends upon the point of observation, means whether it is a Bombay, Delhi, New York, Sydney, Canberra, anywhere. They will change depending upon geographical location. And Hg we want to HO we have to calculate. Here S maximum we have to calculate HO. These A and B are given. S will be given. HO we have to calculate. S maximum we have to calculate. S maximum already we have calculated by using equation. First we have to go by because a geographical point. For example, Mumbai. Given location is 19 degree and 77 degree. So this is phi. and this is not required here because only thing that we need is phi, and because we have to find out omega s equal to cos inverse minus tan phi and tan del. We have to find out phi already we get by using geographical position, and del, tan del we have to calculate del by using equation 2326. This equation you have to remember, sine 350 upon 365 n plus 284. And already we have calculated for example day of the May. 15th May is representative day of whole of the month एवरेज, पूरे महीने का जो एवरेज है 16 मई है, तो 16 मई के लिए जो n होगा वो कितना होगा, n इक्वल टू 136. By putting this value you can find out del, and once we get del we can find out omega s by putting this value, and once we get omega s then s maximum equal to already in our previous lecture we have defined omega is equal to 2 by 15 s omega s. That omega s is in degrees, always in degrees. If it is given in the radians then we have to calculate by multiplying it 180 by pi, we get converted into degrees, then we find out s maximum. Now we get s maximum, s is given, a and b is given, so find out ho means monthly daily average of the whole of the month when radiation is above the atmosphere, means extraterrestrial region, means radiation are counted, measured over the horizon of extraterrestrial region, means there is no atmosphere. So h, how we can find out ho? ho equal to isc 1 plus 0.033 cos 350 n upon 355 into integration of cos theta for whole of the time day or whole of the day. So this is the equation by which we can find out ISC is solar constant, and value of the ISC is 1367 and 1 plus 0.033 cos 360 n upon 365 and cos theta integration dt. So let us see, reducing once again. Let us see how because this theta is not integratable with respect to time. So we know that t equal to, already we have defined t equal to omega into pi omega. If omega is given in radian, so omega upon pi omega pi into 180. T can, if omega is given, omega is given in radian, then easily can you find t equal to omega by. If it is not given in radian, then you have to calculate it by t equal to omega into, if given in radian, then pi by 180 by pi into 15. If omega is given radian, here t equal to, now dividing it by 12, so 12 by pi into omega, t equal to 12 by pi omega, provided that omega is given in radians. This equation we are going to use, particularly we are going to use because omega in equation will come both in radian and degree. That's why we are using this equation that omega is given in radians, then convert into degrees by multiplying 180 by pi and dividing by 15 to get in hour. So that becomes 12 by pi omega. So dt equal to 12 by pi d omega. Now putting this value of dt in this equation, ho equal to 1367 1 plus 0.033 cos 350 n upon 355 and integration cos theta d omega into 12 by pi, 12 by pi. So 12 by pi you put forward, and equation minus omega s to omega s. Then now it is integratable, minus omega s to plus omega, because you know that up to this time 6 a.m. 12 p.m. to 24 p.m. 6 a.m. Here time 90 degree and again 90 degree. That's why multiplied minus omega s to plus omega s. Here minus omega s and plus omega s, like this. So that's why minus omega s to, if we change minus omega s to plus omega s, 0 to omega s, then we have to multiply by 2. So equation now become 24 by pi into 1.367, converting into watt into kilowatt, because and multiplied by 3600 also, because this is given in watt means kilowatt means kilojoule per second, so we have to convert this is in hour. We have calculated time in hours, so multiplied by 3600, and 1 plus 0.033 cos 350 n upon 350 n upon 355. Now integration 0 to omega s. Rest of value we have to write here, multiplied by cos theta, multiplied by sin del sin phi, plus cos del cos I, and cos omega d omega. Integrate this one. This value should be here, and d omega and d omega. This value will be here. So integrating this value and applying limit, we get equation 24 by pi into 1.367 into 3600 into 1 plus 0.033 cos 360 n upon 365, and in bracket we get omega s. Integration of this sin del not integrable, cos del is constant, and d omega equal omega, and putting value omega s, so become here omega s sin del sin phi plus cos del cos phi sin omega s. And only thing that we have to require is putting all values. Here you have to put omega s in radians, all values in angles, the rest of values in angles, n will be equal to 136, and putting all these values we can get HO. HO means global daily average irradiance falling on horizontal surface for clear day, means extraterrestrial radiation falling on the extraterrestrial region, monthly daily average value HO bar. After getting this value, everything is now known, and we have to use equation. Hg upon HO bar equal to A plus B S bar upon S maximum bar. So Hg equal to HO bar A plus B S bar upon S maximum. In questions, this value is given, this value we can calculate, this value is given, this value we have just explained how to calculate HO bar, means average of the irradiance falling on extraterrestrial region, average of daily average monthly basis falling on the extraterrestrial region. SG means global irradiance average monthly basis, daily average monthly basis falling on the horizontal surface. ABR linear constant. S is a value of the average of the per day solar irradiance sunshine. This is the maximum possible sunshine or whole of the day, that is a monthly average. Means S, if you want to hours per day, this value kilojoule per day per meter square, kilojoule per day per meter. These are constant, these are values by using this equation, because this is very important. Why? So because whenever we go to plan, we have to go for feasibility study whether this site location is suitable for installation of the solar power plant based on thermal or both of, whether it is thermal or photovoltaic. You have to calculate by using SG. What is a daily average monthly basis? On monthly basis, what is a irradiance falling on the ground? That is important. If this value is very less, then the installation of power plant will be not suitable and it will be loss causing. So before going to install this, we have to find out this value. This value should be around 20,000 kilojoule per day per meter square. That should be value. This should not be less than this value. Otherwise, installation of the solar power plant, whether it is thermal power plant or photovoltaic power plant, will not be feasible. That's why we have to search areas, for example, Jaisalmer, Jodhpur, any arid zone region is highly suitable for installation of thermal power plant based on this solar energy. So this equation is very important, and this calculation is very important. And I think this is the very easy only thing that we have to know different step calculation of S maximum and calculation of HO. Thank you very much for watching and have a nice day. Please like, share and subscribe. Thank you very much.